Hello and welcome, Nikki here for another Ansible demo. So in today's video I want to just show you how you can use Ansible Handlers, which I think is a really useful Ansible feature. So what is a handler? Basically, a handler is a task that is only run when another task makes a system change. So we'll demonstrate exactly what that means in a couple of minutes. But first, just having a look at the lab. So what we have in each of our switches is three VLANs, VLAN 10 for data, 20 for voice, and 30 for wireless. And if we have a look at show IP in brief, we'll see that we're on site 2, so we encode a site ID of 2 into our 3 VLANs IPs, which gives us 10.2.10 for VLAN 10, and on site 3 that would be 10.3.10. So in this video, what we're going to do is we're going to manipulate the BGP policy. Currently, there's a redistribute of OSPF on these two routers, and it doesn't try to tweak any of the BGP metrics. What that results in is that the two core site routers prefer router 1 with the lower BGP peer ID or router ID for all of its connections. So all of the traffic from other sites will come out router 2. So what we're going to do in this one is we're going to take one of the VLANs, VLAN 20, and outbound we're going to tweak the BGP med value to be lower so that the two core sites for VLAN 20 will come in via the router 2 links. So what happens usually with BGP is if you make a change to the BGP policy, such as tweaking the med, it doesn't take effect until you clear the BGP session. So if you're using soft configuration, then that's going to be a hitless change. But in order to demonstrate handlers, I'm not using soft configuration. So what I need to do is I need to clear my two BGP peers on router 2 and site 2 and site 3 in order for them to take effect the change that I've implemented. So if we just look at site 1 router 2, and you can see where our starting point is. So if I do a show IP route and I include for the 10 network, which is 10.0/24, or the 20 network, or the 30 network. Right, so pipe include. We'll see that the metric value, the second value here, is the same for all of the three VLANs in the two sites. And we learn via in site 2 10.2.0.6 and for site 3 10.3.0.6. So the .6 is the router 1 in the two sites. So what we want to do is for the 10.2.20 and the 10.3.20, we're going to change the med to 5, and then we should see that this is learned via site 2, which if I remember correctly is a .14 address. So if we just have a look at the Ansible host and how we're going to do that. This time I just have my host file as before. The CEs is just site 2 and 3, and there's a site ID for each of my two hosts. And then in my playbook, on the host variable, I'm using a regular expression which starts with the tilde, and then in brackets is my regular expression, which is the host name should begin with S and followed by a number which should be 2 or 3, and then outside brackets dash R2. So that's how I just match router 2 and site 2 and 3. I'll get onto the handlers in a second, but first to go through the tasks for the config of our policy. We're going to configure with the iOS config module an access list 1, that permits the .20 subnet. So we just using the Jinja expression call the site ID. So we'll get 10.2.20 and 10.3.20. Then we're going to configure a route map So the route map, the parent of this route map is going to be a permit 10. We're going to call it set-med. We're going to match our access list 1, and we're going to set the metric to 5. And then after we configure this, then we just configure a second permit statement so that VLAN 10 and VLAN 30 will still be passed and won't be dropped. And then for the actual BGP config, I'm using the iOS BGP module. So there is some debate on whether Ansible is imperative, which means that it's instructing the router on exactly what commands to run, or declarative, which focuses on what needs to be done, not on how it needs to be done. So I think that this is, to me, it's declarative because we're passing in some parameters, but we're not saying exactly how it's been configured. But the address family is in there, and the redistribute command, and make up your own mind on whether you think this is declarative or intent-based networking, as they call it nowadays. So that's our 3 modules. So if we run these, or rather our 3 tasks, if we run these 3 tasks and they result in config being applied to the router, i.e. it hasn't already been applied, we then need to clear the 2 BGP sessions on the routers. So we could have a 4th task that does that clear IP BGP, but what will happen is that because Ansible is idempotent, when it logs into a router, if you were applying this policy to say 50 routers, but some number of them already have it applied, when it hits a router that has these 3 tasks config already applied, it will do a diff, and it will realize that what it is trying to do is already configured, and it doesn't configure it. If you have a 4th task that's clearing the session, you've now needlessly cleared the BGP session. So how do we only clear the session when we've actually made a modification to the config? And that's what the function of a handler is. So a handler reacts to that changed variable. When we run Ansible playbook command, you will notice that every time you change the configuration, you'll see that the changed variable is set, and it's shown in the output. So it watches out for that changed variable, and if a task calls a handler, it will run the handler if a change has been made. So what we've done on our 3 tasks is we've called 2 handlers, one called clear BGP neighbors to do the clear, and one to save the config. So this is declared outside of our tasks in a handler section at the top of our playbook, and they just look like normal tasks. The first one, to restart the BGP neighbors, is an iOS command, so an imperative module, and we're clearing the BGP peering to the site 1, router 1 and router 2, and again we're programming the site code with the Jinja expression into it. And with the listen command, we're calling this via this expression here, clear BGP neighbors, which we can see in our tasks with the notify subsection here. And then our save config is also iOS config, and it just is save when always, so it just does a simple copy run start. So if any of these 3 tasks here cause a configuration change on the router, we will run our handlers. The nice thing about the handlers is that it will only run once. So even if all 3 modules cause a change on our router, the handlers will still only run once. So let's have a look at how that works. So let's run our playbook, calling the host file, and we configure our access list. And we can see that the change variable is set for site 3 router 2 and site 2 router 2. The exact same thing with our task to configure the route map and our task to configure BGP. And now we're calling our handlers to restart the BGP sessions and save our config. So you can see that that the handlers, even though they were called in each of our 3 tasks, that each handler is only run once. If we were now to go back to our core site, you can see that we have some logging output where the 2 BGP sessions were reset. And if we run that same command that I run previously, we can now see that the VLAN 20, the 10.220 and 10.320, our MED has been modified, and we're now learning that via the .14, which is the router 2 in the 2 sites. So that's the outcome that we wanted. However, as we were saying, the handlers are only called if a change is made. So if we run the playbook again, the second time round, because of the diff that Ansible does, the item potency check, we can see we get an OK message on our 3 tasks. We're not getting a change, therefore the handlers are not run. So that's it, a short video just to demonstrate handlers. I think it's really useful, and it can be used in lots of different other scenarios, so that if you're doing something and you make a change, then you can call another task. It might be a save config, but it could also be a task that captures output because a change was made, like I've changed the routing and I want to capture an output to make sure that the routing has been changed in the routing table the way that I intended. And I hope that you find that useful and enjoy that video. Thank you very much.